Welcome to Methamphetamine. Today I'm going to introduce 10 special functions to you guys, and I'm going to talk about their graphs. And let's go. Here's the first one, the graph of EL f of x. This is the above function, the above function. So the above function is graph is like this. Don't forget to put the x and y axis. And here, from here, and then approaches to 1, but not exactly 1. It approaches to 1, like that. 1. And also, ELF of x is an R function, so you can just do the mirror. Do mirror here, and then this approaches to this kind of ugly, but this approaches to be -1 here. What? Since it's an R function, you see. Here's the deal. When we take the limit, here's the graph of the above function. Right. When x is exactly 0, you can see ELF of 0. ELF of 0 is just equal to 0. Right? And also, let's talk about infinity and negative infinity. Put it inside, but please allow me to put infinity. Just put an infinity inside. Negative infinity and then ELF of infinity, like that. Because I just want to this faster. You can also just take the limit, but let me just do this as consider infinity is a number. It's a number. ELF of negative infinity. You see, this is approaches to -1, like that. It's keep approaching -1, but it's not exactly -1, but this really closer to be -1. So ELF of negative infinity is equal to -1. Since it's this ELF of x is an R function, so ELF of infinity is just equal to 1, like that. Because you see, when x is approaches to infinity, and then it's going to be 1, right? Like that. And this is really cool. And here is an example of a famous integral question, the Gaussian integral. The Gaussian integral is e to the power of negative x squared from negative infinity to positive infinity to is equal to square root of pi. Like that. This is the Gaussian integral. I will do a proof of this later. What is square root of pi? But we can also do it. We know that from negative infinity to positive infinity, from negative a to a. Since you know that this is an even function, this entire is an even function. You can put a negative x inside. You can check this an even function, so you can double the result. 2 times from 0 to positive infinity from e to the power of negative x squared. Yes. Let me just do this in our integration way. So here you should memorize the integral of e to the power of negative x squared is equal to square root of pi over 2 times, because this e to the power of negative x squared, this is the negative, so we're gonna use the original above function, ELF of x. And don't forget to put 0 and infinity later on. So 2 and 2 they are cancelled, so you can get square root of pi ELF of infinity. Let me just distribute the square root of pi. And then subtract square root of pi times ERF of 0, like that. Here's the deal. We know that the answers to this integral is equal to square root of pi. So, if we don't know the graph of this, can you draw conclusions to this? We have some cases. If we don't know the graph of Yao f of x, case 1, Yao f of infinity is gotta be equal to 1, right? Because if Yao f of infinity, we assume that we don't know what's the graph of Yao f, and the definition of Yao f of something is equal to 1. Why? Because you see, this answer is equal to square root of pi. We don't, if Yao f of 0 is equal to 0, and 0 times that, you just can, the square root of pi is gone. So, it's not good though. And another situation is Yao f of 0 is just equal to 0, like that. So over, you just subtract zeros over, you just get square root of pi. But we also have another situations. Case 2, like that. Yao f of infinity. Let me just consider this equal to 0, like that. And then, what's Yao f of 0's gotta be? We want this to be equal to, we want a square root of pi here, but we assume that Yao f of infinity is equal to 0, so this is 0, and then negative square root of pi times something. Yao f of 0 is gotta be negative 1, right? Because Yao f of 0 is equal to negative 1, assume this is equal to negative 1, so negative and negative they become positive. So this is just the answers to this Gaussian integral. But if you are not sure, but you really need to check the graph of Yao f of x. Otherwise, you will do a mistake here. Yao f of infinity, be sure this 1. And Yao f of 0 is just equal to 0 and not equal to negative 1. So sometimes you really need to check the graph. So square root of pi, like that. Yao f of infinity is equal to 1, and then Yao f of 0 is equal to 0, like that. And number 2, let me just do this really quick. Number 2 is the graph of the imaginary error function, d. We should use d here because it's an e. D imaginary. Imaginary is start with I. So you need to use the d and not the. So the graph of Yao f of I of x is the imaginary version of the error function, and its graph is really different compared to Yao f of x. Its graph is like that. And this really is really a simple one, just like that, and it's also an R function like that. This really simple, right? So you see this, when x is approaches to infinity, and this answers Yao f of x is gotta be infinity as well. So let me just consider Yao f of I of 0. You see, check the graph of this. Y is equal to Yao f I of x. It's just equal to 0. It's really easy. And you see, this graph, look at this graph, is pretty much just an R function. So Yao f I of infinity, pretty much you just get infinity. And then Yao f I of negative infinity, pretty much you can just put the negative outside, so you just get negative 0. So this is negative infinity. So this is just due to negative infinity, like that. Approaches to negative infinity. It's really simple, right? So number 3. EI of x, the exponential integral, EI of x. And this graph is like that. These are kind of weird one. From the positive part, and this is approaches to 0 like that. And for the negative part, it approaches to, when x is approaches to infinity and is going to be 0. Like that. This is really weird. The graph of EI of x. So this is the graph of y is equal to EI of x. And of course you can try the Wolfram alpha, and you see it's keep going on. The ELF of x is, I know I draw kind of ugly, but so when EI of infinity is pretty much, you just get infinity, right? Just keep going to be infinity. That's when you do EI of 0, and this is kind of different. When EI approaches to be 0, or you can do 0 plus or 0 minus, you're also gonna get approaches to negative infinity. Is approaches to be negative infinity. Negative infinity. Yes, you can try the graph. And EI of negative infinity. Of course, this not EI of x is not an R function or neither an even function. But EI of negative infinity, you see, when x is an extremely small number, negative really small number is approaches to 0 like that. You should memorize this, I think. Okay, number 4. And this is a really unpopular one. And it's called the complementary error function. Complementary error function is ELFC of x. And this is a really weird one. Complementary error function. And it look like this. And it approaches to be 2. When x is an extremely small number, it approaches to be 2. Like that. And it keep approaching to be 0 like that. Yao f of c. Yao fc of x like that. So you can check the graph. ELFC of, I kind of forget. Let me just check Wolfram alpha. I'm sorry guys, because this really unpopular one. I kind of forget it. If you check Wolfram alpha, ELFC of 0, I forget. Sorry. This is 0 to 1. So my graph is really ugly. It should be down, more down, like that, more down. I should draw more clearly. Like that. 2 and then ELFC of x. This approaches to 0 when x is approaches to infinity like that. This one, so ELFC of 0 is 0 to 1. ELFC of infinity is equal to 0, and then ELFC of negative infinity, this is a special one, is 2. This approaching 2, right? So number 5, what's that called? Let me write here. The sine integral, SI of x. I should draw y is equal to ELFC of x like that. I forget to put the x and y except, but I think it's okay. And SI of x is really fun, and this an even function, and it's really cool, really cool. The graph of SI of x is like that. Go from here and then go down, and then it start to become a way, and then it's keep getting smaller and smaller, and it's about to be a line here. So it's approaching something, right? When x is an extremely big number, and let me tell you, it's approaching pi over 2. This is a really special one. Since I've already told you, SI of x is an even function, a function, so you can just do the image. First you go down, and then the wave, and then keep getting smaller and smaller and become a line like that. So it's the graph of y is equal to SI of x like that. So you can check the graph. This is SI of 0 is exactly 0. That's SI of 0 is equal to 0. And then SI of infinity is equal to pi over 2. And the SI of negative infinity, since it's an function, so it is approaching negative pi over 2 like this. The next is approaches to negative infinity, and then it's approaching negative pi over 2 like that. It's really cool. And also we have an famous integral like that, from 0 to infinity, and then psi x over x dx. And this is equal to pi over 2. A really famous one. From 0 to pi over 2, you pretty much just get. From 0 to infinity, pretty much just get pi over 2. But if we want to do the calculus way, so the integral of psi x over x, this is the psi integral, right? SI of x from 0 to infinity, so you can get SI of infinity minus SI of 0 like that. So if you are not sure about the graph, so be sure you need to memorize SI of infinity is just pi over 2, and the SI of 0 is just 0 over, you get pi over 2 like that. Number 6, CI of x, the cosine integral, and its graph is really different compared to SI of x. This graph is like, it only has the positive CI of something. And okay, CI, when x is approaches to 0 plus, because x cannot be a negative number, as the graph tells you. So it's approaching 0 plus, and it's approaching negative infinity like that. So it's like a wave like SI of x, but it's kind of different. Just like that. It's around the keyboard, keep spinning around the x-axis like that, and then go. This is the graph of y is equal to CI of x like that. So over, you can check the graph of this CI of infinity. This approaching, when x is approaching infinity, you pretty much just get 0 like that. When CI is approaching to 0 plus, let me just put down a 0. Consider 0 here. Is equal to negative infinity like that. So we don't have negative infinity since x cannot be a negative number like that. Oh, I forget one. Number 7. This is a really important one. Why do I forget? And this really similar to Ci of x and Ly of x. It's called Ly of x and is the Li of x. Li of x, its graph is look like this. It's only have the positive, and this the logarithm integral. X is need to be greater than 0. Like that. So Li of something. I forgot something. And this is really interesting. When I type Ci of negative infinity inside, you get I pi here. And this is the imaginary number. And this is really cool. You can tell me why. Why this is due to I pi, Ci of negative infinity. So you can check this by your own. Let me just talk about this. Ly of x is like this, from 0 and then go down and then go up again like that, and then it's keep approaching to positive infinity, and this about 1 like that. When x is equal to 1 and it's approaching negative infinity, so we can call the graph y is equal to Ly of x, and Ly of 0 is exactly 0, and Ly cannot be a negative number as well. And then Li of 1, this really special. Li of 1 is approaching to negative infinity, and then Li of infinity, pretty much you just get infinity like that. And another 3-1, I think they are kind of. The number 8 is a fun one. This is called the hyperbolic sine integral, and this is Shi of x, like that. And its graph is just really simple, just like Fi of x. And this graph is just like that. Go up, go down, and it's an R function as well. And this is the graph of y is equal to Shi of x. So you can do this really quick. Shi of 0, check the graph, you can get Shi of 0 is equal to 0. Then Shi of infinity, approaching infinity, you just get infinity. And then Shi of negative infinity is just equal to negative infinity. And this is a very simple one. However, Chi of x is kind of weird. We know we have a hyperbolic sine integral. We also have a hyperbolic cosine integral. Unfortunately, we don't have the hyperbolic. We don't have the integral of Ti as well. So as Thi of x. They both do not have. I don't think we have a function like Thi of x, Thi of x like that. And Chi of x, its graph is. It's like Lnx, it's just Lnx, but it grows way slower, or as slow as Lnx, like that. And the x, you need to be greater than 0. The x should be greater than 0 like that. And it's the graph of Chi of x. So you can check the graph. This Chi of infinity, pretty much you just get infinity. But Chi of 0, this approaching negative infinity. This is not happy. I think the function of Chi of something is Chi of 0, you get infinity, negative infinity. This function is kind of tough, right? You get negative infinity. However, whenever I typed Chi of negative infinity is actually give me positive infinity. I don't know why. I think you can tell me why CHI of negative infinity is equal to infinity, and I'm not sure about it because we only have the positive graph, right? So let's move on. I think it's the most special one in this video, the number 10, and it's called the polylobism integral, right? Li2 of x. And its graph look like this. Let me talk about the negative part at first. If this negative is keep approaching to negative infinity, when x is approaching negative infinity but x approaches to negative infinity and its value is approaching to negative infinity. So okay, from here to here, it start growing, and it's okay, right? But whenever it reach 1 here, and here is the point, Ly2 of 1 is equal to pi square over 6, and this is the theta. It reminds me some theta, right? Theta of something. Pi square over 6. And then whenever you reach when it reach x is equal to 1, and this line just turn around, just go up like that. Go up. And then keep approaching to 0. When x is an extremely big number, it's keep approaching to 0 like that. So over you can get Ly2 of negative infinity is equal to negative infinity, and then Ly2 of 0 pretty much you just get 0, right? The Li2 of 1 is a special one, and this pi square over 6 like that. And then finally Li2 of positive infinity is equal to 0 like that, approaching 0 like that. So that's our video, and this is really cool, right? So peace out. On the next video, I'm going to do the integral of all of these functions at once. Bye.